Hello everyone. In this video we're going to be solving a logarithmic equation with different bases. We have the common logarithm base 10 on the left hand side, log x, and we have the natural log on the right hand side, which is ln, but ln of 2x. So we have log x equals ln 2x. Let's go ahead and use the formula. Let's just use ln ab equals ln a plus ln b on the right hand side. So ln 2x can be written as ln 2 plus ln x. If you substitute that, you get log x. Allow me to write without parentheses. I hope it's understood. Log x now can be set equal to ln 2 plus ln x. I can kind of like put the ln on the left hand side, so I can kind of write it as log x minus ln x equals ln 2. And the purpose here is to bring the logs together and leave the constant on the other side. Can we subtract logs? And the answer is yes, but in some cases only. So for example, we know that log a minus log b is equal to log a over b. Of course, a and b both have to be positive. B should not be 0, of course. When they're positive, can't be 0. Come on. Anyways, but the idea here is, and we can place any base here, but they have to be the same base. So this formula only works when they all have the same base. What happens if these two logs have different bases? Can we subtract? Not as is, but we can do something. And change of base comes to the rescue. Change of base. Change of base is a very important formula, and it can be proven obviously by using definition of logs, because any property can be proven using definition. So how does that work? So if you have log, I don't know, x with base b, and you want to change it to from base b to base a, you can just write this as log x with base a and log b with base a. Notice that x goes here and b goes here, and the bases are the same. That's how it works. That's change of base. Let's go ahead and do that to our equation. So one more time, our equation is log x minus ln x equals ln 2. By the way, ln 2 is a constant. It's a number. We don't care what it is exactly, because we're not looking for a numerical solution. Like, we're not doing numerical analysis. We're kind of looking at it from an algebraic standpoint, whatever that means. Anyways, so let's go ahead and use change of base. Which one should we use? Doesn't matter. At the end, you're going to get the same answer. But let's just stick with ln, because ln is more fun or cooler. I don't know. So let's go ahead and change this. Remember, this is base 10. So I can write log x as ln x over ln 10. This is actually one of the easiest conversions because they are spatial bases. Now, they have the same base, but I do have an extra constant at the bottom. Don't worry about it. Doesn't matter, because we can take it out. We can take out ln x, but let's go ahead and make a common denominator maybe first. Okay, ln x minus ln x times ln 10 divided by ln 10 equals ln 2. And then cross multiply. Ln x minus ln x times ln 10 equals ln 10 times ln 2. Okay, ln 10 does not equal 1. Be careful. Log 10 is equal to 1 because it's base 10, but this is a different base. Make sense? Now let's go ahead and take out ln x. We can factor, and we get 1 minus ln 10, and that is equal to ln 10 times ln 2. One thing I want you to notice, ln 2 times ln 10 is positive, but 1 minus ln 10 is negative, because ln 10 is greater than 1, because 10 is greater than e, which is the base. Make sense? So we're kind of dealing with a negative quantity here, right? And what is going to happen? Let's go ahead and check it out. Okay, so we're going to go ahead and divide both sides by 1 minus ln 10. By the way, Is it possible to get a negative answer? Yes. ln of something can be negative, but something cannot be negative. Like x cannot be negative in this case, but ln x can definitely be negative. Because if you think about the graph of ln, part of it is actually under the x-axis, right? Okay, great. So I got ln x. I'm almost there. How do I get x from here? So I just need to do the following. X can be written as e to the power ln x. Of course, x needs to be positive, needless to say. And it is going to be positive. So I can now write this as e to the power ln 10 times ln 2 over 1 minus ln 10. You can leave it as is, but also do a little bit of manipulation here. So for example, this can be written as e to the power ln 2 to the power ln 10 over 1 minus ln 10. So kind of like keeping the 10s together and putting the ln 2 or tucking it inside. But e to the power ln 2 is just 2. So now this is kind of like changing the base, but not log base, but exponential base. So we can kind of write the x as this, an exponential expression like this one. And now let's take a look at the graph. Would you like to see the graph? How that works? Let's go ahead and take a look. Okay, so I graphed both of these functions for you, y equals log x and ln 2x. Notice that they kind of behave in a similar fashion as x approaches 0 from the right, but as x gets bigger and bigger, they kind of spread out. And of course, in the middle somewhere, they intersect. And notice that the x-coordinate is positive, but the y-coordinate is negative, right? And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.